Continuing with the concepts of networking, the aim of this video discussion is understanding the IP addresses, elaborating on different internet protocol versions we have. I'm talking about IP version 4, then talking about netmask and subnetworks. Basically, we call them as subnets, and then classless inter-domain routing notation, CIDR notation. So these are the things I will be discussing in this discussion, and very informative content by DigitalOcean. I'll share the link in the video description, and very easy to understand. So I will elaborate on this content only. So I'll start with the IP addresses. So IP addresses are used to identify the source and destination when the communication is happening and over a network or multiple networks. Transfer of data in packets has to happen between source and target, which will have certain addresses, because otherwise the packets won't be able to travel without having a source and a destination. So every location or device on a network must be addressable. As you can see over here, it's written. This is a term that means referencing under a predefined system of addresses, right? So we call them as IP addresses. So IP addresses allow network resources to be reached through a network interface. If one computer wants to communicate with another, it can address the information to the remote computer's IP address, right? So assuming two computers are on the same network, or that the different computers and devices in between can translate, the computer should be able to reach each other. And this is possible only when we will have certain mechanism to address those systems, those nodes, those machines on network, right? So that is basically the need to have addressable nodes, right? So each IP address must be unique, isn't it? Otherwise it will create problem, right? So uniqueness of IP address is a must to uniquely identify the nodes or machines in the network or devices in the network, right? See, networks can be isolated, right? Multiple from one another, isn't it? The system called network address translation, as you can see over here, right? It allows the addresses to be rewritten. One packet traverse network borders to allow them to continue on to their correct destination, isn't it? So this allows the same IP address to be used on multiple isolated networks while still allowing these to communicate with each other if configured correctly. So what we are basically trying to achieve is, through network address translation, even if on multiple isolated networks the machines have same IP address, and it's a possibility, right? So but still, if the communication has to happen from one network over to other network, we should be able to translate the addresses correctly, isn't it? So despite having same IP addresses to be that are getting used in multiple isolated, we are still having communication. So communication is happening, right? So through the system called network address translation. Okay. So the next discussion is on the version of IP protocols, version 6 and version 4. So version 4 addresses are basically 32-bit addresses, the most common IP addresses that we see in our day-to-day life, where we have 32-bit address. of a system, of a node, of a machine, isn't it? It is basically Internet Protocol version 4 address. So 32 bits are there, okay, and we can represent them as octet, each expressed as a number, isn't it? And they are separated by a period. So as you can see, a typical IP version 4 address looks like this, right? So these are the numbers, and the lowest value in each octet would be 0, isn't it? When all the binary digits are 0, it will be 0, isn't it? And the highest would be 255, right? So we are talking about binary system over here, where all the binary digits in one octet would be 1. That would be equivalent to 255, right? So there are two formats basically. One is IP version 4 and another IP version 6, as you can see over here. And see the IP version 6 expresses addresses as an 128-bit number rather than 32-bit, isn't it? So this means definitely more combinations, isn't it? More space, more network space basically, because we'll be able to achieve more network, more IP addresses. We can roll out more IP addresses in a network, isn't it? Because we are using 128-bit number, contrary to what we are using in IP version 4 as 32-bit. So less number of IP addresses configurable in IP version 4 compared to IP version 6, which have a noticeable difference in the address space, and that is this number basically. So extended address range is definitely one of the advantages of IP version 6, right? And that is the reason it is getting popular nowadays. Okay, so over here we can see here IP version 6 is generally written out as a 8 segments of 4 hexadecimal digits. So these digits are hexadecimal digits basically. So hexadecimal numbers, number system we are all aware. So that is being used, to represent this 128-bit number. Okay. So coming on to, so basically it is nothing. It is this hexadecimal, right? Hexadecimal digits, there are 8 segments basically. 1, 2, 3, 4, 5, 6, 7, 8, right? So coming on, so these were two different protocol versions that I wanted to discuss, and then next is the IP address ranges that we will be talking about. And so there are different classes based on the number of bits that we are setting. So if the first bit of an version 4 address is 0, that means it belongs to class A. This means any address from 000 to 127, because the first bit has to be 0, isn't it? So these are the address ranges in class A. Okay, and then class B includes the addresses that have 1 for their first bit and don't have a 1 for their second bit. Okay, so this is how the segmentation is happening based on different combination of bits in version 4. Different classes are getting defined. Okay, and coming on to net mask and subnets. So when we are defining a network, right, what we are talking about is we are talking about a set of nodes, right, a set of machines that are communicating with each other over a network, isn't it? And those machines are identified by certain addresses. We call them as IP addresses, right? So a network would be having a set of IP addresses, isn't it? So whenever we are defining a network, we will have to roll out a range of IP addresses that can be assigned to the machines, that will be allocated to that network, isn't it? Now, this is one scenario. Now, to make, network more manageable, we introduce a mechanism called as subnetting, right? Where we are dividing the network into smaller network sections, right? and it helps isolate groups of hosts together, isn't it? So